Hello everyone to the second episode of Distributed Systems 101 course. So what we are doing is that we are trying to cover distributed systems, the introductory concepts of distributed systems in this series. So in my previous episode, that was the first episode of the series, we discussed about what are distributed systems, how do they work primarily, like how a distributed, what is the need of a distributed systems, how do they get introduced into the system, right? What complexities do they bring in, right? And now what we'll do is that we'll cover about one of the topics. So basically in this lecture, I'll cover about replication and we'll primarily focus on replicated state machines, right? So before going to the replicated state machines, let's discuss what is replication. So uh, let's focus on replication first. So what is replication? So basically the term replication, you can think of it as duplication, right? Duplicate. So what happens is that if we are making a duplicate copies, or we are making a duplicate replica, or we are making a duplicate machine to handle increasing load or for fault tolerance, then that process is called replication. So currently what we can say that if we have a client, right? So suppose here we have a client and we have a single server or a machine, right, that is responsible for getting the request and returning a response from the client, right? So a client can send a request and the server will send the response. That is a pretty simple architecture. But what will happen if this server fails? So suppose if there is any failure happens, and what happens if this server fails, right? So in that case, our client will not be able to send any further request. So if a client sends any request further to the server, it will get an error response, or maybe a no response because the server is not up currently. So in these situations, what we can do is that we introduce replica servers. So what we will do is that in these failure situations, we will have multiple other servers as well. So maybe this can be a replica server, right, which can get live when this server goes down. So suppose this server fails, then this server will get live. So what will happen is that now this server is live. Now what can happen is that now from now on, all the requests of the clients can be directed from this server to this replica server. So instead of going to the primary server, since this primary server is crashed now, it can be directed to the replica server. So all the client requests will go to the replica server. It will get to the replica server and it get the response from the replica server. This makes sense. So this is the need of replication. Now, what are the replicated state machines? So I'm gonna clear this frame now. So let's talk about replicated state machines. Okay. So in the replicated state machines, what we can see is that suppose there are a number of clients here. So we have C1, we have C2, we have C3, so on. We have Cn clients, and all these can send their requests to the server. So for them, this can be a single endpoint, but under the hood, what can happen is that there can be multiple servers. There one can be a master server and another can be replica server, or one can be a primary servers, one can be a primary machine, right? And the rest of them can be the replica machines. So we can say that this is replica hash 1, this will be replica hash 2. So all these are like, suppose a primary machine goes down, then these replica servers will support the system, right? And in this way, the client can send the request and they all can send their request, and these machines are responsible for sending their responses back. So this is basically a replica state machine. Now, what we'll discuss here, we're gonna see a simple replica machine, a very simple replica state machine, replicated state machines. We'll discuss how a client can send a request to it, how they handle failure, right? How the fault tolerance mechanism looks like, and at the end we'll discuss the output rule. Cool. Okay. So let's focus. First, let's look at the simple replica machine. Okay. So simple. So for the sake of our simplicity, we will keep two machines. So one will be primary and another will be a replica. So one is the primary machine or maybe a server, right? And the another one is the replica. Okay, this is a replica machine. Okay, now as usual, we'll be having a client, right, which has no idea about the what is happening under the hood. For the client, it is like we basically have an endpoint to which it will gonna send their request and they will get the response. And they don't know what happens under the hood, right? So what the client will do is that client will send a request to it. So suppose the client send this request. Now what request will what will happen here is that the request will be sent to the primary machine first, right? Now, if the request will go to the primary machine and the request will go to the primary machine will perform over the request do all the necessary operation which needs to be done, and then it will share the response back. So I'm gonna change the color. So suppose it sends the response, res short for response. Okay, so suppose it sends the response back. Now what will happen is that the same thing should go to the replica as well, right? So once it returns the response, the same request will be sent to the replica machine as well. So what we will do is that we'll send the same request from here to the replica machine, just for the sake that though these both machines should stay in sync. So this request will go to the replica machine as well. The replica machine will also perform all the operations in a similar way the primary machine does, and it will gonna generate a response, right? So in the very similar way, the replica machine also generates a response. Now here what will happen is that only the primary machine is allowed to send the response back to the client. The response from the replica machines will be discarded because we don't want multiple machines to be sending the same response to the client, right? There should, since client does not have any idea about what is happening under the hood, the client thinks that there is a single machine which is responsible for performing their operation. But we under the hood for fault tolerance, right? We are maintaining the replicas. So what happens is that the response of the replica machine is discarded, right? So this will be discarded or this will be dropped. And the response from the primary replica will be returned to the client. Right? Pretty simple. So in this way, this simple replicated state machine will function. So at high level, what happened is that client sent the request to the primary machine. Primary machine performed all the operations over the request, generated a response. Then the request was also sent to the replica machine. The machine also performed all the necessary operation and generated a response. But the response of the replica machine was discarded and the response of the primary machine was sent to the client. Okay, that makes sense? Great. So now, apart from that, let's discuss the fault tolerance. So uh, we have this primary machine and replica machine for the sake of fault tolerance. Now let's understand how this replicated state machine handles the entire fault tolerance mechanism. So I'll just clear this off. So just right here, fault tolerance. So fault tolerance and replicated state machines. So what can happen is that as I we discussed about this scenario previously as well. So I'm again draw the same architecture here. So we again have a primary machine and we have a replica machine. We have a primary machine and we have a replica machine. Again, we have a client. So this client can send the request to the machine. Now, again, the client does not have any idea about what is happening under the hood. We are like maintaining the primary and the replica machines. So what the client can do is the client can send the request and can get the response back. Very simple. All the things we discussed previously. But now what will happen is that what if the primary machine crash, right? Got crashed at some point of time. So what should we do here? In that case, we need to back up the replica machine. Now, so we discussed the situation previously as well. So what if the primary machine, if what if there is an issue in the primary machine and the primary machine got shut down or got dropped off from the system? So in that case, what should ideally happen is that the client from now on should send their request to the replica machine and then should get the replica machine should be able to get the response back, right? These are the two things. Now, here we discussed previously that any response generated by the replica machine is dropped by the system. But here there's a different condition. So here during the fault tolerance, if the primary machine has if the primary machine has been dropped or the primary machine is no longer in the system, then the replica machine will start acting as a primary machine. And as a result of that, any response, any response which is returned by the replica machine will not be dropped off from the system. So the response of the replica machine will not be dropped off and it will be sent to the client, right? It will be ideally sent to the client. This is one of the major change that will happen once the primary machine has been dropped off from the system, right? And another change is that any request from the client earlier was sent first to the primary machine and then it was sent to the replica machine. But now what will happen is that any request from the client will be sent directly to the replica machine instead of going to the failed primary machine. So any request from the client will no longer be sent to the primary machine. So now primary machine will not be responding and ideally all the client requests will directly be sent to the replica machine. The replica machine will process over these requests and it will return the response. So in this format, the fault tolerance will happen. So we discussed about the two changes here. Now let me clear this off. The diagram we have drawn. Just clear it off, all the stuff. Okay, we cleared it off. So we discussed about two things. Two things happened in the while during the fault tolerance. So first thing that happened is that any request from the client will be directly sent to the backup replica. So request from client will be now sent directly to the backup replica, right? Since our primary replica has been shut down and it is no longer into the picture. The second thing which will happen is that it will the system will no longer discard or drop the response generated by the backup replica, right? So these are the two things happen. Request from the client will now be sent directly to the backup replica and the system will no longer drop the response which is generated by the backup replica, right? So these are the two things. which happen during the fault tolerance scenario. Okay, I believe the fault tolerance is clear. Now we will move to the output rule. So before moving to the output rule, we will see a one situation where data discrepancy or a data inconsistency can happen in these replica state machine, and then we will discuss how we can solve this using the output rule. Okay, for that I'll just clear this page. Let's see a situation. Just make it a situation. Yep. Okay. Cool. So now we should see this very carefully. Again, we have a primary replica and we have a backup replica. Okay. So this is the primary replica and this is the backup replica. Now let's assume that both these replica have a data item into it, right? So suppose both the replica has stored a data item X whose value is 10. Okay, let's assume this. Now what will happen is that we have a client. We have a client here who wants to perform an increment operation on X. So basically what he wants is that he wants to perform an increment, right? Let's say INCR on X. So if we have to do that, what he does is that he sends an increment request. He sends this request to the primary replica, right? What primary replica does, primary replica performs this operation, right? And after performing the operation, the value got changed from X to 10 to X to 11 because it's an increment operation. And this was the response. Now, before that, as we discussed that in this replicated state machines, all the requests which are sent to the primary machine will be sent to the backup replica or a backup machine, right? So the same request, the same INCR request from the client gets forwarded to the backup, right? So again we have an INCR X which is forwarded to the backup client. Okay, or a backup replica. Sorry. Now the backup replica will perform all the operation over it, and this will also be changed to 11. It also returns a response, right? Now both the primary and the backup machine have generated their response, but as we discussed previously that the backup machine or a backup replica is not allowed to send any response back to the client. So ideally this response should be dropped. So what we'll do is that we're gonna drop this response. So this response will be dropped by the system, and only the response from the primary replica will be sent back to the client. And what will the client get? So the client will get the value of X equal to 11. This is a very general uh, thing which will happen during a replicated state machine. But what we will see that how an data inconsistency situation can happen. So let's think. I'm gonna clear this off. So let's think again. We have a primary replica, right? We have a backup replica, or we have a primary machine and we have a backup machine. So let's name this primary and we have a backup. Okay, both the machines are here with us. Now, same situation, we have a data item X will be equal to 10 stored by both the machines, right? Similar thing, a client is here which wants to perform an increment operation. Okay, so the client wants to perform an increment operation over X. Now, what happened is that again, in a similar way, the primary replica performed the increment operation. But now what happened is that it has the response, it has generated the response, but before sending the response, so it has the response, it sent that response to the client. Now, what was supposed to happen is that this primary replica would need to forward the request to the backup replica, but before forwarding the request, the primary replica got failed. Now, listen, pay attention here. So, what has happened is that the primary replica has generated the response. It has sent the response back to the client, but it was not. But after that, as soon as it sent the response to the client, the primary replica failed, and hence it was not able to send the request to the backup replica. That is why the backup replica does not know anything. So what has happened here is that at that point, since the primary replica has failed, although the client has received the updated value of x, but the backup replica does not know anything about it, right? So in that case, what has happened is that in the primary replica, the value of x, the data item x, is 11, but on the backup replica, the value of x is still 10. And that is an issue, because what if next time the client wants to send a request? So again, next time the same client wants to send a request to the system. So we discussed previously that when a primary replica is down, the backup replica will take its place. So all the requests coming from the client will now be directed to the backup replica instead of the primary replica. So it sends an increment request of x to the system, and since the primary replica is down, the request goes to the backup replica that, hey, like, perform an increment on x. Backup replica does not know of anything like what has happened before. So backup replica thinks that, okay, you gave me a request of incrementing, I'll do that, performs all the operation, it increments the x, changes the value of x to 11, and it returns the response. But now the client sees that, okay, I have got the response, but the response is still 11. And client is like, okay, I incremented the value of x and I got 11, and now I'm again incrementing the value of x. I was under the impression that I should get 12, but I'm getting 11. And here is the data inconsistency issue happened, because the primary and the backup replica are not synced with each other. Like, they went out of sync, because the primary replica, when it was supposed to send the request to the backup replica to keep both of the replicas in sync, the primary replica went down, and it was not able to notify the backup replica कि, hey, I have got a request, I have updated myself, I will send you the same request, you update yourself as well, so that we keep in sync and there is no data inconsistency. So this is one of the drawback which comes with maintaining the replica. You have to like make sure that there is no data inconsistency, the data is consistent out of all the machines. So that is one of the failure, and now we will understand how the output rule resolve this failure. So let's understand what is output rule. I'm going to clear this up. So what is output rule? So basically output rule says that the primary replica is not allowed to send the response back to the client before notifying the backup replica about the request, or basically before get sending the request to the backup replica and acknowledging the response, right? So in layman terms, what it says is that I'm not going to change the color because it will take a lot of time for me. So this is the primary replica, right? This is the backup replica, right? So if a client sends any request to the primary replica, if a primary replica has generated the response, but still it is not allowed to send that response back to the client, it should first send this request or forward this request to the backup replica, get an acknowledgement back from the backup replica, right? Basically, it should get the acknowledgement back from the backup replica that, hey, I have received your request. And once it got the acknowledgement from the backup replica, now it is sure that, okay, since I have got the acknowledgement, backup replica is notified about the changes. Now I am good to send the response back to the client. So what it does is that it sends the response back to the client. This is the way it happens. And in this way, we will avoid the previous problem. So previously what happened is that the primary replica sent the response without waiting for an acknowledgement from the backup replica. And that is why the data inconsistency happened. So in that case, in the previous situation, what would ideally happen is that if the primary replica generated the response, but it will first send the request or forward the request to the backup replica, wait for the acknowledgement from the backup replica, and once it gets the acknowledgement, then it is allowed to send the response to the client. So this is basically the output rule, and this basically avoids the data inconsistency, right? So if I have to write the output rule, so output rule says that the primary replica is not allowed to send any output response back to the client until the backup replica acknowledges that it has received all the event records till that point. And that is basically what we discussed in previously in the output rule. So this is basically in the definition of the output rule here, that primary replica is not allowed to send any output response back to the client until the backup replica acknowledges that it has received all the event records till that point. Okay, I believe this clear. Okay, great. Now at the end, I would like to talk about one thing which I guess we got missed in the while discussing about the fault tolerance scheme, that how does the backup replica will know that a primary replica has failed, right? So this happens by the simple a very famous mechanism of the heartbeat or the interrupt signal. So what happens is that I'm gonna write here heartbeat or interrupts. So what happens is that uh, if this is the primary replica and this is a backup replica, or let me draw it rightly. So this is the primary replica and this is the backup replica, right? This is the backup replica. This is the primary replica. So primary replica will keep on sending some interrupts, right? We can call it an I, or it is basically like a heartbeat at some instant of time. So let's see at an every t instant of time, the primary replica will keep notifying the backup replica through the interrupt that hey, I am alive. And in this way, the backup replica knows that okay, the primary replica is alive and it is responding to all the client requests. But what happens if the primary replica goes down? So if the primary replica goes down, these interrupts will stop. The interrupts will stop from flowing from the primary to the backup replica. So now what happened is that the interrupts are stopped. Now the backup replica is not receiving any interrupts from the primary client. So what backup replica does is that backup replica waits for some t instant of time, which is obviously greater than small t. And what is small t? Small t is basically the time lag between the interrupts. So it waits for t amount of time. And since t amount of time is greater than the time gap between the interrupts, since it has waited for this amount of time and it has not received any interrupt, it will be for sure, it will be completely sure that the primary replica is not able to send the interrupt and there is something wrong with the primary replica. And at that point of time, he understood that, okay, the primary replica has failed or is down. And what it does is that it converts itself into the primary replica. And at that point of time, all the requests from the client, the system will start sending it to the backup replica instead of the primary replica. So now, so the requests were going to the primary replica, but now since backup replica knows that okay, primary replica has died, all the requests will be directed to the backup replica, and the response of the backup replica will not be dropped by the system. So ideally, the response generated by the backup replica will flow back to the client. So yeah, this I wanted to cover. I guess we skipped in the fault tolerance part, but yeah, this is the entire thing I wanted to discuss in the replicated state machine. I guess yeah, we have covered most of the topics: the output rule, heartbeat, interrupts, fault tolerance. I think it got clear, and yeah, uh, I hope you guys like this lecture. Uh, I'll be coming up with more lectures like this under the series soon. So yeah, if you liked it, like the video, share the video, and subscribe to the channel. It would help.